The focus of this video lesson is Accident Investigation Data Part 3. Example 1. An auto accessory maker wants to test a new type of roof strap. Cargo is secured to the roof of the car. The car is remotely operated and travels at 50 miles per hour before hitting a concrete block head-on. It was hoped that the straps could withstand the force of the impact. The cargo was secured at a height of 5.5 feet above the ground. Unfortunately, as soon as the front of the car hit the concrete block, the straps snapped, and the cargo went flying off of the top of the roof on the path illustrated below. How long did it take the cargo to hit the ground? And what horizontal distance will it travel? All right, using what we know about physics and projectile motion, we're going to start by creating a formula that represents our vertical distance. Now, we know that vertically, the only thing pulling down on this object is gravity. So we know that our formula will be of the form y is equal to negative 16.1 t squared plus h naught, where h naught represents the initial height of this object. Negative 16.1 is half the force of gravity. So we know our h naught, or initial height, is 5.5. So we know that our vertical distance can be measured by negative 16.1 t squared plus 5.5, where t is in seconds and y represents the vertical height of the object. The first thing we're going to do is determine how long it took the cargo to hit the ground. We know that the cargo will be at the ground when the height is 0 feet. So we're going to let y equals 0. All right, so let's substitute 0 for y and let's solve for the time. So we have 0 is equal to negative 16.1 t squared plus 5.5. Our objective is to get the variable t by itself, so let's start by subtracting the 5.5 from both sides. On the right-hand side, they cancel. On the left, we get negative 5.5 is equal to negative 16.1 t squared. We're going to now divide both sides of this equation by negative 16.1. Using our calculator, we have negative 5.5 divided by negative 16.1, which is approximately 0.3416. So t squared is approximately 0.3416. Now we'll square root both sides of the equation to get t by itself, and we get 0.3416 square rooted. We get 0.58 approximately. So we're going to say our time is about 0.58 seconds. All right, so that answers the first question. Now our second question is about horizontal distance. We know in physics, horizontal distance is measured as x is equal to our initial velocity, or speed, times time. In this case, we know that our speed is 50 miles per hour. However, we know that our measurement is in seconds. So we're going to go ahead and we're going to convert 50 miles per hour into feet per hour and then into feet per second. So we know that there are 5,280 feet in a mile. Therefore, there are 264,000 feet per hour. Now, we want to convert our hours into seconds. So we know 1 hour has 60 minutes, and 1 minute has 60 seconds. So doing this conversion gives us 26,400 divided by 60 divided by 60, which gives us 73 feet per second. So we know that our horizontal distance can be modeled using x is equal to 73 times t, our time. In this case, our time was 0.58 seconds. So we get x is equal to 73 times 0.58 seconds, which comes out to be about 42.34 feet. So the horizontal distance traveled by this cargo is 42.34 feet. The vertical distance is 5.5 feet, but the time it took is 0.58 seconds. So in 0.58 seconds, less than a full second, the cargo traveled over 42 feet. So there are two formulas here you really want to take note of, right? Our vertical distance formula, which, like I said before, is the force of gravity pulling down on the object in relation to seconds squared plus the initial height, and the horizontal distance formula, which is x is equal to the initial velocity or speed of the vehicle in feet per second times the number of seconds. And it's super important that you remember to do your conversion. So if your speed is given in miles per hour, convert it into feet per second. Now it's your turn to try. Had the above car been traveling at 35 miles per hour before impact, the projectile motion equation would be y is equal to negative 16.t squared plus 5.5. How long would it have taken the cargo to hit the ground? What horizontal distance would it have traveled? Give it a try.